Good morning, Juan.
Good morning.
Today we continue with implementing the dog-cat classifier. Last time we had a very short introduction to programming in Python. Today we're going to focus on the data, on this cloud of example of XY, where X is an image and Y is the labeling, either a dog or a cat, okay?
Okay.
So I will share my screen now. Just a minute. Please tell me if you can see my screen.
Not yet.
You see it?
No, now I see. Yes, no.
Okay, so I will open a Colab notebook. As we explained, Colab is a Google tool that lets us program in Python without installing anything. It's a tool that I like. So I will go again to my Google Drive. Actually, I already opened such a notebook in order for us to have a link that we need. It's almost an empty notebook. All we have is this link here, which is the link I prepared in advance to a set of images of cats and dogs. So what we'll do now, I will add a very, I must say another thing. Here in this little window, we used to write Python code, right? Like that. We did something like a print, oh, sorry. A print hi and run it. This is Python code, but we are running on a virtual computer. So this Python code is actually, we are on our browser, but we are running on a virtual machine, which means that, let me show you. For example, we do have, let me delete it. We do have a file system. We do have a operating system. We have everything. Let me show you. For example, I can do, whenever I do a, how do you say Siman Kriya in English?
Exclamation mark.
Again?
Exclamation mark.
Exclamation mark.
Is clear
Okay.
with you.
So if I start by this exclamation mark, I don't execute Python code, but rather a shell command. Do you know Unix?
No.
Never? Okay. ls in Unix is show me all your file in my current directory. So I run this. I can see that I have only, okay, maybe I will execute a shell command in order to download a file with the images of dogs and cats. So I start by this exclamation mark, and wget is a Unix command or application for download a file from the internet. I will call this file dataset because it will be the set of all my images. And I will call it dataset .zip because it will be a compressed file. And I will download it from this address here. I will copy it, copy link address, and I will just paste it here. So what you see here is a wget, which is a shell command, calls the download.
What is the -0 there?
It's not a 0, it's a big O, which means the name that I want to choose for the file that is being downloaded will be dataset.zip, and the URL an address in the internet where the file exists. I will execute it. Okay, it was downloaded really quickly. I will refresh here, and you see this file, dataset.zip. It was just loaded. You can see its size is 1.5
Where did
megabytes.
it exist before?
It didn't exist before. Maybe it was
Imported something.
In the beginning, it was there because I downloaded before and then I deleted it. Look, I will delete it and download it again. Just a minute. I will delete it now.
Download from where?
From the internet, from a URL, an address
that you
that
knew
I
before.
have.
Okay, I didn't know it. Okay.
Actually, this address is in my drive also, but it doesn't matter. Now the file does not exist. You see, there's no file here that is named. I can, just a minute, I will ask to see all the files. ls is a list of the files. I don't have, this is the directory. I don't have a file named dataset.zip.
Okay.
Let me delete this. Is also something that reminds from previous stuff. Okay, let me download it again. So I'll run this command again, wget, okay. Now it was downloaded again. I will refresh the file system, and here you see dataset.zip just appeared. And if I will execute the ls again, let's see what I'm going to see. This was not here before. Okay, this is the file that was downloaded. But you know, .zip means it is a compressed file. It actually means Lempel and Ziv compressed it, your colleagues. You know something about the compression algorithm? You know it's not lost?
I knew it once, but I forget. But the principle is always the same. Frequent strings get low code, a small code, coding number.
Yeah, frequent is short and unfrequent is long, right?
That's the general principle, yes. Okay.
Yeah, but with the same principle, you can do many different algorithms. And what is so beautiful about the algorithm is that they are actually building a dictionary while compressing it. But let's leave it. Now I don't want it to be compressed, so I'm gonna extract it, like and decode it actually. So this is unzip. It's another shell command.
What does the exclamation mark do? It means they're going to.
It's not a Python code. It's a shell command for the virtual computer.
And exclamation mark is, I'm going to print now some command. That's what it means?
Yeah, a command for the operating system and not a Python code.
Okay.
That's what it means. So unzip, I could have called it unlempelzived. Unzip the file, which is dataset.zip. Let's see what's going to happen. Just a minute, I will refresh here. Oh, this is something I wanted to delete. Just a minute, delete folder. Are you sure? Yes. Okay. It's not empty, so it is not deleted. I will just rename it. Just a minute. Rename folder. I will call it old folder. We're not going to use it. This is old folder. Now I'm going to unzip the dataset file. Let's see what's going to happen. You saw that inflating, many cats and dog files. You see inflating DS will be a directory just created. So he created a new directory not named DS for dataset. And inside this directory, it puts many, many files, cats and dogs. Okay?
How many?
Actually, it's 100 cats and 100 dogs.
Okay.
It is not enough. A data set should be much bigger. But we're going to start with a small one just for the example, okay?
Okay.
Let's open one cat and one dog. You see this cat? Let's open a dog. You are capable of telling which one is a cat and which one is a dog, right?
Yes, by now, yes.
This
is distorted. Okay.
But you see, it's already labeled because the file name already tells me whether it's a dog or a cat. So we have a labeled data. I must admit that I took care of this data. I downloaded it from a site named Kaggle for a competition in deep learning, but I did it. I already pre-processed all the images to have the same size exactly. So that's why there are sometimes you can see they are scaled. For example,
distorted, yes, okay.
Yeah, this is not the right ratio. But never mind. We have
width-wise, yes.
Yes, I like scratch it. Anyway, so we have what we need. We have many labeled examples. So let's start working with it, okay? I'm closing the file system. I don't need it. I'm also closing all the images of dog and cats. We don't need them either. Here we just saw that everything was inflated into the directory DS. We don't need that either, so I will remove this output. It's very verbose, it's very long. So, okay, now we can start working, because if I do a ls and ask the system I have a DS folder, I can also ask what's inside DS. It will tell me in DS you have all those files. We are fine, we can start working. It's 200 files. So first, what we need is some package that will enable us to load a JPEG image. Do you know what JPEG is?
I used it. I don't know what the initials are for.
I don't know either what the initial stands for, but what's the essence of it?
Just images. I don't know what's special about it.
It's also a compression algorithm using a Fourier transform, which is a lossy compression algorithm. It drops information that you don't really see in your eyes, but makes the file much, much smaller, okay? So in order to decode such a file, I would have needed many, many lines of codes to decode the Fourier transform, but I don't want to do it, so I'll just use a package of Python. This I will use a package called peel.
Package for unzipping, for decompressing, yes?
For loading an image, which also means I need to decode it, I guess. Okay, so import peel. It is already installed on my system. So all I need to do is import peel. Now I have it. I can enjoy all its capabilities. This is something which we talked about last time, that Python ecosystem give me so much free capability that I can use. Let's ask a little bit about peel just to know what it is. I will do help peel. pillow fork of the Python imaging library. It's a whole package of dealing with images. Okay? So this is peel. Now I'm going to use peel. I will use it as follows. Peel.
There's an extra
Peel. Yeah. Peel. Inside the peel package, I have an object or class named image, which represent an image. And I will, I think I need to load it or something, load or read, or I forgot. Read. No, I forgot, so let me check. I have another example that I've written. Just a minute. I know what I will do. Just a minute. Bugs of Zoom are making it hard for me to, just a minute. My drive. This is another notebook I was playing with. It's actually what we did last time. Here. Open. What I needed is open. Okay. So every library chooses its own name for the functions, and this is expecting open. I need to give it a pass.
Open is a known command or something you defined for yourself before or something? What's that?
The programmer of peel, which is a library written in Python, chose to program a class named image. And inside this image, he decided to program a function named open. And I'm using it now.
Okay, so the dot is for containing. Image is some file, some library, and in it there is a file called open or program called open.
Peel is
I
a
wondered what is the
library.
dot for? Peel dot image. So it's inside, it's a hierarchy, right? Okay.
Dot in Python means that the image, the image is inside peel, and the
That's
open is
hierarchy, yes,
inside
okay.
image.
Okay.
But I need a specific file. So let's copy the path of this file, and I will paste it here. This is an absolute path. I can give it just a relative path from where I'm standing. So now I'm opening a specific file, the file of cat number 10144. Let's see if it's
Open is
work.
decode. I mean, open.
Yeah, you can see that
JPGs.
decoding.
Okay.
Yeah. Let's see if it works. Okay. Ugly cat.
Yeah.
I think. But anyway.
Distorted, I think. He used to be beautiful, but you distorted him.
Maybe I made it ugly. Yeah, it's maybe my fault. Let's put it inside a variable. So IAM will be a variable containing this image. In Python, we can always ask for the type of an object. For example, if I'll ask type of 7, it will tell me that it's an integer. Int. It's short for integer. If I'll ask the type of a list, 1, 2, 3, it will tell me that this is a list. If I will ask for the type of a string, it will tell me that it is string. Hi. This is a short for string. But if I'll ask the type of IAM, I will get the type that the programmer of Pil chose for that. You see, it's a long type, but it's a JPEG image file. You see? Okay, fine. Now I don't want it to be JPEG image file. I want it to be a tensor, a three-dimensional array of numbers, plain and simple. Okay, so we need to convert it.
Why three-dimensional?
Why
I thought your images are two-dimensional.
So. Yeah, two-dimensional for width and height, but it's colorful. It has red, RGB, red, green, and blue.
Okay.
For each pixel, you have three numbers. Okay? Okay. So I'm going to import a very, very useful library called NumPy. NumPy will give me the capabilities very similar to MATLAB. Do you know MATLAB?
No.
Okay. Sorry. So it will help me dealing with matrices, with tensor, with all kind of numerical computation. Very, very useful. Almost every scientific program in Python uses NumPy. Okay, it's considered very basic. Did you notice what I did here?
No, what is S? You mean you give it some label?
It's just a shortcut. I don't want to write all the time numpy dot.
Okay. S is short. Yes.
Import numpy and call it np for short. Okay. This is very, very useful. It's also a convention. So now I have np. I will do the conversion. So img, the new image, is np. And now I'm going to use the most useful for us type. We'll call it array. It's actually a multi-dimensional array, a tensor array, and I will initiate with im, which was the JPEG image. Okay, so this is the conversion of the JPEG image into a tensor.
Image is NP. NP was what? That's NumPy. NumPy turns something into a vector. So what does it do? NumPy is
NP is the name of this package, NumPy, and I was asking for
array. Okay,
array,
which is inside, which translates your image into an array. Okay.
Yes. Okay. So let's do it. Okay, so if I'll just ask him to show me what image is, he will show it to me as numbers. Okay. What do we see here? It's kind of strange. Why it's 3 on 3 and what's going on here? So it's hard to understand. Many, many numbers. Yes. It doesn't make any sense. But let's ask him, instead of showing us the image like that, we'll ask for its shape. Its shape is the dimension of the tensors.
Yes. So it must be a 3 at the end, yes? Something 3.
Yeah, look, let's see. It's 3 numbers.
203, yes.
You understand what? So width, height, and clear. Number of channels.
The numbers I saw there had more than 3 values in the last coordinate. So which was strange because you said there are only 3 colors.
Okay. Now let's try to understand. Why is the tensor encoded as such? We're going to have 3 by, it's not 3 by 3, it's actually 3 by hundreds, by 200. And then we have 200 of these. You know, you can flatten any tensor, right?
Yes.
So it's just, it's not something very smart. It just, you know, the first dimension is this one.
The coordinate, the coordinate in the first dimension. But no, I don't understand. What does the 92 stand for? It doesn't represent colors. Where is the color here?
Okay. All the number here are number between 0 and 2055. You know what's special about 255?
255. It's
Yes,
256 minus 1. Yeah, so it's
exactly.
2 to the 10
Exactly.
minus 1. And to the 8.
So it's 2 to the power of 8 minus 1.
Yes.
What is special about 2 to the power of 8?
We don't know why 8 of all numbers.
You know the notion of byte?
Yes.
What is a byte?
It's a digit somehow.
A byte is 8-bit.
I see. 8 bits, okay.
So bit is the most fundamental unit of data in computers.
I must
It's
say,
either.
I'm ashamed of my ignorance. I'm ashamed of my ignorance. I hear the name bytes all over the place and never knew that it's 8 bits. Okay.
Do you know what a kilobyte stands for?
Yes, that's 2 to the 10 more or less, no? A kilobyte, 1,000 bytes.
Some people think it's 1,000 bytes, but it's not. It's 1,024. It's 2 to the power of 10. Yeah. And what giga stands for?
That's a million, no? Or
almost. It's 2 to the power of 20. Okay. It's almost a million. It's a little bit more. It's a square of 1,024. And giga is 2 to the power of 30. Okay. So a byte is considered like also a very fundamental unit of information in computers, 8 bits, and each number in this tensor is actually a byte. So how many colors can we decode? The
tensor has 3 dimensions, right?
The tensor is 3-dimensional tensor. In each pixel, we have an image of the size 200 by 200. And in each pixel, we have 3 bytes that represent the color. The intensity of red, the intensity of green, and the intensity of blue. Yeah. RGB. So how many colors do we have? We have 2 to the power of
to the 8 times 3, because no.
Yeah, 24, right? 8 multiplied by 3. Okay, the letters. So how many?
Why 2 to the 24?
Because we have 3 bytes, right? 3 bytes. So we have 24 bits.
Yes. Okay.
Right? Yes. So
you have 3 bytes, and each byte represents an intensity of a color.
Exactly. Okay. So the number of combination, we have 256 options of red, 256 option of blue, 256 option of red. So all the option altogether is 2 to the power of 24. Okay. Which is like 16 millions, more or less, right? 16 millions color. Yes. A lot of colors. Okay. Fine. So let's see the image now. I need to import another tool. I will import matplotlib. This is also a very useful library for plotting mathematical figures.
Can I stop you for a minute? You
Yes.
said that there are 2 to the 8th possibilities for green, say. Do you need
Exactly.
so many? You need 2 to the 8th? You need to
Yeah,
find
yeah.
256?
Let's write it down. 2 to the 8th.
Why not 3? I mean, 10 possibilities. You don't discern it.
Two is
so
for
many.
bits. 2 for bit. Each bit can be either 0 or 1. A byte is 10 bits. So
yes, but you encode how the intensity of color green in honest pixel by 256 possibilities. Do you need so many? This is,
that's another question, whether I
very,
need so
very
many, but
wasteful.
we're just talking combinatorics right now. So what I did is 2 to the power of 8 multiplied 2 to the power of 8 multiplied 2 to the power of 8 equals 2 to the power of 8.
That's fine. But
Okay.
our
So
eye cannot be so sensitive as to distinguish between 256 shades of green.
I don't know. Actually,
Even in the movie, it's only 50 shades. Okay.
Maybe even my screen is not sensitive enough to show me the difference of all the. But I can encode this number of colors, and the computer can distinguish between them. Maybe I cannot see them. Maybe the screen cannot show me. I don't know. But I think my eye can distinguish many different colors. Actually, if we want, we can make experiment, change it by a little number and see if we can see the difference between 2 pixels which are different.
Okay.
We can make an experiment. Okay, so
sorry for this, right? Yes. Okay.
Okay, so matplotlib. For matplotlib, which is a library of plotting images, I will take only one thing, pyplot, and I will call it a PLT. This is also not something that I invented. It's a conventional. PLT will use us, will serve us for plotting. So this is an importing command. Now I can do PLT im show, which stands for show an image, and I will ask him to show IMG, my image. Okay. How do I remember it? Because I use it a lot.
So PLT is plot. What does plot mean? Means
PLT is it's a tool for plotting graph, images, many things. So here I plotted the tensor actually. So it showed me, you see, it's a 200 by 200. It showed me the numbers here, the x's. Okay. I did nothing interesting, just technical to show me an image. But now I can do much more. For example, let's see only the first half of this cat. So I will copy this command, and I can slice the tensor. For example, I will want only the red part of it. So I will do something like this. A comma means all, select all. This is select all, and this is a image. 2 dots, and 0 means only the first channel. You understand?
No, 0 in third coordinate. So only
if I wrote 1 and 2, this would have given me a byte.
Yes.
Look. Oh, sorry. What? My mistake. Just a minute. Sorry, my mistake. Let's do it like that. This is. Oh, just a minute. Okay. Now I've asked for the pixel in the place, or the byte in place 1,
2, and red.
Yeah, this is a pixel, this is a byte. It's actually the red in the place of 1 and 2.
Yes.
Like, okay. This is a specific specific a pixel.
Pixel, yeah.
But I could have asked for a range of pixels. For example, 1 to 3 and 2 to 4 or to 5. This will give me a matrix, actually.
Yeah.
Have a look. You see, this is a matrix.
3 by 4 matrix.
So I can ask for a range. Yeah. And if I just put a comma, it means all of them. Like this, it's all of them. 200 values.
Not comma. I forget the name of the nekudatayim.
Yeah. Okay. This is 200 by 3.
Okay.
Okay, fine.
So
now
2 to 5 is between 3 and 5, or between 2 and 4, because 2 to 5 is has 4.
Yeah, we need to keep in mind two things: that the indexing is starting from 0, so 2 is the third element, and also we need to keep in mind that all the ranges are close open. It means it includes 2.
Okay, from 2 to 4.
Exactly. Yes, this is the convention. Now let's see this image. So I will write a PLT im show of, but now I want all the image, but only the red one. Okay. Let's see. You see what happened? This is just one, but
that's it in blue for some mysterious reason.
First, it is considering this tensor to be a grayscale image because it doesn't have channels. It has only one channel.
Yeah.
But it uses a color map that is kind of weird. Let's give it a better color map. It means what color to use. I will tell him this is gray. Okay, now what?
He knows the word gray. Okay.
He doesn't know the word gray. Just a minute. He knows the string gray as the CMAP parameters. It means use the gray color map. Let's have a look. You see?
Yeah.
Okay, but now let's look at only half of the image. So we can do something like that. You remember the image size is 200 by 200, right?
So you do it to 100, okay.
So this is all the number till 100. It's 0 to 99. Let's see. Half an image, okay?
Yes, okay.
Now let's look at for example, a quarter of the image, because I slice also the x-axis like that. This is a 100 to 199. You see, this is quarter of the image.
No, right.
So I can slice it. Okay, so we have tensors. We have 100 tensors of cats and 100 tensor of dogs, and we know the label of each one. Now we want to make a list of all our labeled example, X, Y, X, Y, X, Y, something that we can work with, right? What's the time? Oh, it took us a lot of time. Maybe it's a good place to stop, and we'll continue next time with
okay, yeah, it's a bit technical. Okay.
Yeah. We need to go through it, the technical part.
Okay.
Any question about that?
No.
Okay. really technical.
Not that I can write these things myself, but you can follow. Okay.
Okay, so thank you, Ron.
Okay. See you.
See you. Bye-bye.